should wrap up even and odd. All right. Then we're going to go to section 2.5. We're going to look at functions in general. And you can see that there are, actually I was going to say 12. I think there are 12 basic functions. In this chapter, we're just going to hit 7 of them. So here we go. Here's the idea. We are going to, I don't know about you, up here when I was doing all these tables to graph, this got really tedious, and I don't like to use tables. I like shortcuts. And so what we're going to do in this section is we're going to use tables to get an idea of some basic functions. Y equals x, y equals the absolute value of x, y equals x squared, y equals x cubed, y equals the square root of x, the cubed root of x, and 1 over x. Okay? And then anytime we see something that has an absolute value, we're going to be able to use this function to help us know what it looks like. Or anytime we see a square root function, we're going to be able to use this function to help us know what it looks like. So that's really the goal here. So I would encourage you to actually pause the video and go through and fill the tables out on your own. I think it would be really helpful for you. Notice we can't take a square root of a negative number here. We can take the cubed root of a negative number, though. Kind of cool, huh? I don't know what the cubed root of 2 is off the top of my head. I'll leave that for you to punch in your calculator. -8, -2, -1, 1, 0, 0, over 1 up 1, and over 8 up 2. This is a cool function, I think. I don't know why I like it. A reciprocal function. Here's why. If you take 1 divided by -1/2, you could type it in your calculator and see, or you can multiply by the reciprocal, and you get -2. At 0, it's undefined. 1. right, so you could take a look at these. I'll maybe put it on the screen so you can pause it and compare it. But these are the 7 functions we're going to work with. All right, how are these useful? I think normally I would have you do a little activity with this. Little notation. These are all functions. And this is saying if I have a function and I add or subtract a number behind it. So let's just do a couple examples. Let's say I used the function any of the 7 that we just did. So let's just pretend for a moment that b equals 2. So I'm going to run out of space here. Let's say b equals 2. Let's do this with the squaring function. Or we could do it with the absolute value function. Or we could do it with the cubed root function. Doesn't matter. Any of those. What's going to happen to my xy values? I don't think this is going to do what I want it to do, but I'll try. Yeah, I was afraid it would just get the numbers. Okay. Think about y equals x squared. If I have -2, -1, 0, 1, 2. If these are my x values and my y values, -2 squared is 4, 1, 0, 1, 4. Okay, and so you can picture that. 0, 0, 1, over 1, up 1, and then over 2, up 4. We get a parabola shaped. But now, what if I think about y equals x squared plus 2? What's going to happen? I think you can see this, can't you? -2, -1, 0, 1, 2. Plug -2 in, I would get 4, but then I need to add 2 to it. So this becomes a 6. Same way here, -1 squared is 1 plus 2 gives me 3. 0 squared plus 2 is 2, 3, 6. And so notice what happens. I probably should have a nice graph here, I'm sorry. Instead of going 0, 0, I'm at 0, 2. You see it moved up 2? Instead of being at -1, 1, and 1, 1, I'm at 1, 3. And instead of going over 2 and up 4, I'm still going over 2 and up 4. It just happens to be from a different origin. Okay? So I know that's a lot there, but plus b is just going to move the function up 2. Minus b is going to move the function down, I guess b. It depends what that number is. B. So let's try another example here. Yeah, let me just delete all this scratch. Let's try y equals the absolute value of x plus 2. So normally, notice it would just be 3, 2, 1, 0, 1. But the plus 2 is just going to move everything up 2. So this is going to be 5, this is going to be 4, this is going to be 3, 2, 3, and so on. So instead of having my graph look like this, can you picture it? It's just going to be shifted up 2. All right. Something weird. Okay, let me pause there. Quick summary, because I don't want you to lose it. This is the key idea. When it's adding b and it's outside the function, it moves up b units. When it's minus b, then it's moving down b units. Now what does this mean? X plus or minus d. How does that compare to this one over here? Actually, I'm going to leave that yellow. The contrast here, plus b is on the outside, the plus d is on the inside. So what does that look like for a function? If I look at an example. Well, before I said y equals x squared plus 2. And you see the plus 2 is on the outside of the function. It's not in the x value. Here I'm replacing the x value with x plus or minus d. So what I need to do here, instead of putting the 2 on the outside, I need to put the plus 2 with the x. Now what's this going to do? This is a little tricky. Let's think about 0. I'm just going to do positive numbers for a second. 0 plus, or for this one. 0 squared is 0, 1 squared is 1, 2 squared is 4. What about this one, though? If I want to get the origin, kind of that center point, 0, 0, what number do I have to put into my function for x? You see I have to put negative 2 in, plus 2 is 0, 0 squared then is 0. And then negative 1, plug that in, I get 1, which is 1 squared, which is 1. Plug in 0, now I get 0 plus 2, which is 2, squared is 4. If I plug negative 1 in, I'm going to get positive 1. So I don't know if this makes sense to you, but over here, this, 0, 0, over 1 up 1, over 2 up 4. For this one, I go left 2 up 0. I meant to put negative 3 here, guys. I'm sorry. Negative 3, 1, negative 1, 1, 0, 4. What do you think negative 4 is going to be? You could plug it in, right? It's going to be 4. So what happens when I add 2 on the inside here? Do you see it actually shifted these points left 2? And we ended up with this. And so when you look at an equation, let's do this equation, the reciprocal one. Y equals 1 over x plus 3. You hopefully are seeing, hey, I see the reciprocal function in disguise, right? What's happening to this reciprocal function? It's moving right 3. Since it's moving right 3, I'm said right 3. It's plus 3. But what does the plus 3 do? It's going to have the same impact that the plus 2 had here. It's going to move it left 2. So this is going to move left 3. So I know without graphing any points that this is going to look like this graph, only everything's moved left 3. So instead of having my graph centered on the y-axis, my graph is going to be centered on the line at x equals 3. Go ahead and type this in your calculator. See, you get that function. Isn't that cool? Alright, so the key takeaway here is plus d inside the function what's it going to do? It's going to move left d units. What do you think it's going to do if it's minus d inside the function? It's going to move right d. That's going to look like donuts. D units. All right, so key idea. Add or subtract outside, move up or down, matching the sign. If it's on the inside, it's going to be opposite of what you might expect. If you're adding, it's going to go left. If you're subtracting, it's going to go right. All right, so let's take a look here. What happens if I multiply by a number where the a is? So let's think about y equals 3. Actually, let me make this. Let me make this 4 square root of x. If you think about our xy, our normal square root of x, oops, wrong button. Our normal square root of x, we can't graph any negative numbers. We would get 0, 1, 2, 3 when we take the square roots. But here, when I multiply it by 4, what's going to happen? I'm still going to have 0. 0 times 4 doesn't change anything, but here it's going to be times 4, times 4, times 4. Do you see my graph went from this to now it's going to be 4 times stretched out. 0, 0 is still the same, but instead of 1, 1, it's going to be 1, 4. Instead of being 4, 2, it's going to be 4, 8. And so it's going to look similar, it's just going to be a lot taller. And so here, when a is a number greater than 1, we're going to have a vertical stretch to our graph. So it'll be these basic functions only stretched out, up and down this way maybe, or up and down this way maybe. But if a is between 0, 1, it's going to be a vertical shrink. And hopefully that makes sense to you, that this multiplying by a is just going to take the y values and multiply them, and so it's going to stretch them out. This one is going to be a little tricky to understand. When the c is on the inside, y equals the square root of 4x. We have our xy table here. For y equals the square root of x. What happens when I put the 4 in there? Zero is fine, right? I plug 0 in, it's going to give me 0. But if I want to get 1 as my y value, I need to put 1/4 in. I don't know if that makes sense. If I put 1/4 in for x, 4 times 1/4 is 1. The square root of 1 is 1. To get 4, I'm going to have to put the number. To get the same y value as 4 in the x value here, I'm going to have to put the number 1 in for x, because 1 times 4 is 4. The square root of 4 then is 2. And then this is going to be the same way. It's going to be 9/4. When I put 9/4 in, times 4 is 9. The square root of that is 3. And so when I go to graph this function, 0, 0 is fine. Where before I had 1, 1, I had maybe 4, 2, 5, 6, 7, 8, 9, 3. Now, sorry. Now I've got 0, 0, still the same. I go to a fourth and 1. I go to 1 and 2. And I go to 9/4, which is 2 1/4 and 3. Y equals the square root of 4x. So I don't know what you're thinking. It almost looks similar to what happened over here, doesn't it? It's a little different process, though. This one is being squeezed horizontally. Did you see the movement was horizontal? Where this one, the movement was vertical. Okay? And so we are going to call this a horizontal shrink because it's going in that direction. So if C is greater than 1, we have a horizontal shrink. And you can explore this on your own. But if C is bigger than 0 and it's less than 1, we're going to have a horizontal stretch. All right. I know there's a lot going here. We'll finish this up here in a second. What's one that I haven't done yet? Let's do y equals x cubed. No, I don't like that idea. Let's do y equals square root of x. I know we just used it, but it'll be okay. So I'd like you to think about that. What about negative signs? What if I put a negative in front of the function? You see here? What's that going to do? Well, let's try it out. Do purple. Y equals the negative square root of x. I've got xy. I could still put 0, 1, 2, or 0, 1, 4, 9 in. Notice I'm skipping because I don't want to deal with decimals. So I picked these numbers. They're nicer. The negative square root of 0 is still just 0, but the negative square root of 1 is negative 1. The negative's on the outside, so that's okay. Square root of 4 is 2 with a negative sign in front of it is going to be negative 2, negative 3. And so if we look at our graph, zero, 0, 1, 1, 4, 2, and 9, 3, look something like this. Purple one though now with the negative sign in front, 0, 0, that's still the same, but now it's 1, negative 1, 4, negative 2, 9, negative 3. This is y equals the negative square root of x. So what did this do? What did this negative sign do? Reflects a function. I'm going to say it this way. Vertically across the x-axis. I don't know if you see it that way. We've got the function, it's reflecting it vertically across the x-axis. This is the x. Okay. We'll come back to this in a minute. All right, now let's look at the last one here, the negatives on the inside, right? We're going to use the same graph here. We're going to do y equals the square root of negative x. Do you see what I'm doing here? Since the negative's inside with the x, I put negative on the inside with x. Now normally I do 0, 1, 4, 9, but if I put 1 in 4 or 9 in, I'm going to have the square root of negative 4. And that's not going to give me a real answer. And so I'm actually going to put negative 9, negative 4, negative 1, and 0. Because what happens when I put negative 9 into this function? I have the opposite of negative 9, or negative negative 9, which gives me positive 3. Plug negative 4 in, I get 2, 1, and 0. Check this out. I think this is really cool. Notice what happens now. Instead of 0, 0, but instead of 1, 1, it's negative 1, 1. It's negative 4, 2, and it's negative 9, 3. Cool, huh? Oops, wrong spot. Alright, so what happens when there's a negative sign on the inside of the function? I'm going to say it reflects the function horizontally across the y-axis. Okay. Now, I know there's a lot there, but let's talk through this quickly. There's some patterns here that will help you remember this. You don't have to just do straight memorization. Notice what's highlighted in each of these. What do you notice about these three things and their location compared to the function? Do you see they're all on the outside? Plus 2 on the outside, times 4 on the outside, negative sign on the outside. Okay? Over here, notice these locations are all on the inside of the function. Plus or minus d inside times 4, negative sign inside. Now look at the movement. Notice this is moving up and down. Vertical, stretch, reflect, vertical, across the x-axis. Whenever it's on the outside, it's vertical movement, up and down. Whenever it's on the inside, it's horizontal movement. Okay? And then from there, plus or minus, that's what we call shifting. It moves it all up or all down or all left or all right. Doesn't stretch it. When I'm multiplying, it's stretching and shrinking. And when you have a negative sign, it's reflecting. The last thing I'll point out is with these two on the inside, it's, I think, backwards to what we would expect. Plus d moves it left. Times c shrinks it horizontally. And so those are some patterns that you can help you to understand this. Let's keep going here. Now to put it into practice. Describe how the graph of the function can be obtained from one of the basic graphs, then graph the function. Alright, so I'm highlighting the cubed. You see that? What basic function do I have, and what is happening to it? I'm seeing the y equals x cubed function. I'm seeing it move, I want to say move left 6, but since it's on the inside, it's moving right 6 and up 5. So if you need to, go back and look at your cubing function. That's what it looks like. You can see 3 kind of points here, and then the points 2, 8, and negative 2, 8. we can do those exact same things down here. I know it's going to be moved right 6 and up 5. That's right here. So the way I think of it is this is my new x-axis. So I've got a point here, over 1 up 1, over 1 down 1, and then over 2 up 8, which is maybe about here. Down, over 2 down 8, 6, 8. And then I can graph my function. And do you see that this purple graph is similar to this blue graph, only it's over 6 up 5. There we go. Alright, let's take a look at the next one. What's the basic function or the parent function that you see here? That's a word you'll see as parent, like kind of like a son and daughter, only a parent. So we've got a couple things going on here. We got y equals x squared. We also have times 1/2 and the negative. Notice these are both on the outside. So 1/2 is between 0 and 1. So this is going to be a vertical shrink of a half. And this negative is going to reflect vertically across the x-axis. So here we go. Normally, a parabola looks like this. And again, let's look at some of these points on this. See it? 0, 0, over 1 up 1 in both directions, over 2 up 2 squared, or 4 in both directions. Alright, so down here we go still 0, 0. I didn't shift anything anywhere. Now, normally I would go over 1 and up 1, right? But now I'm reflecting vertically, so I'd go over 1 and down 1, but the 1/2 shrinks it half as tall. And it's going to be the same on both sides. Normally I would go over 2 up 2 squared, which is 4, but I need to go down 4, but only half that much because of the times 1/2. And if you wanted to, you could go over 3, and instead of going down 9, we need to go down 4.5. Oops, I'm off a point here. And 4 squared would be 16, half of that would be 8. And so hopefully this is helpful for you to see how we can quickly get a graph from here. When I quiz you on this, test you on this, I'm going to have to ask you questions in ways that ask you to explain and describe from the function. Because I know you can type these things in your calculator and look at them, but I really want you to see the connections between the equations and the graphs. And so that's what I'm going to ask you. Maybe I'll even show you something like this and say, where does the 5 in the function, how does it affect the graph? Or something like that. So please do just practice these skills and practice graphing. That would be good. Alright, let's identify the parent functions here, what's happening, and then I have to stop and have class. Here we go. Parent function. Do you see the parent function 1 over x involved? The +3, the -2. Hopefully you see this is outside. So this is going to move it down 2. This is on the inside of the function. So it's going to move it, you might think right, but it's backwards. It's going to move it left 3. So left 3 and down 2. This is my new origin. And then this one I'm okay being a little sloppy, just kind of drawing in these two. Okay. Pretty quick, huh? Quicker than typing it in your calculator, I bet. Here we go, parent function here. hopefully you're seeing the absolute value bars. You're seeing the -2, the -3. Absolute value. Do you remember what that looks like? It's the V shape. ×3 on the outside of the function. It's going to be a vertical stretch of 3. The -2 is going to go down 2. So I go down 2. This is kind of my new origin, so to speak. Normally I would go over 1, up 1, but now I'm going to go over 1 and up 3, because it's 3 times as tall. Do it again, over 1, up 3, and so on. Since it's absolute value, I'm going to have the same in the other direction as well. Alright, thanks guys. I'm going to stop the video here and we'll pick this up another